Hey everyone, this is a video tutorial on how to factor polynomials, all right? So today's title of the lesson is, wait, how do I factor that? So what you need for today's lesson is definitely a piece of paper, all right? You're going to want to make sure that you have scrap paper ready, a pencil ready, and I am going to be giving you guys some practice problems, so make sure you have a colored pen out, so that way you guys can check your work and make corrections just like we do in class. All right, if you don't have those materials, pause the video now and go grab all the resources you need and then meet me back here at the table. All right, so let me get myself situated. So today we are going to talk about, wait, how do we factor that? All right, just a little quick review. When we talk about polynomials, right, polynomials is an expression that contains more than one term. All right, poly meaning many, so it has many terms. The first lesson that we really talked about is how to factor polynomials when my leading coefficient, which in this case is a, is 1. And what's nice about these examples is these are a little bit easier in the sense that we can use guess and check, right? No matter what type of polynomial I'm giving you, the first thing we should always be doing is to see if we can factor out a GCF. That's always your first step, right? Our goal is to factor the polynomial, so we want to see if we can factor out a GCF first. After we do that, we should ask ourselves, well, what factor pairs multiply to get me that final answer of C, but add to get to my coefficient B, all right? No matter what type of problem I'm giving you, your final step should always be to check your work, all right? Multiply it out. You know how to FOIL. You know how to distribute, double distribute. Multiply those two binomials out to see if it comes back to your original expression. And if it doesn't, then you know you did something wrong. All right, so let's get right into an example. Example A is negative x squared plus 4x plus 12. So go ahead and write that one down, all right? And as you do that, I'm gonna set up my paper. It's like TV magic, it's right here. All right, so we have negative x squared plus 4x plus 12. So I'm gonna model for you guys how we go through factoring this polynomial using the steps here shown in the PowerPoint presentation, all right? So my first step is to ask myself, is there a GCF? And automatically I look here and I notice that my first term is negative. So I'm gonna factor out a -1. Anytime your first term is negative, you wanna factor out a -1. So I have -1 times the quantity what? That's correct, x squared minus 4x minus 12. All right, now I have a polynomial with my leading coefficient as 1. We can now go through that process of guess and check. I'm going to leave my -1 on the outside. I'm going to set up my parentheses. I'm going to try to factor this polynomial into the product of two binomials. My first terms must be x, because x times x gives me x squared. Now on the side here, I'm looking for two numbers that multiply to 12 that add up to 4. And notice I'm ignoring the signs for right now. So I'm going to list my factor pairs of 12. I ask myself, what numbers multiply to get me 12? 1 and 12, 2 and 6, 3 and 4. Now looking at my factor pairs, I'm going to ask myself, which one of these factor pairs results in a sum of 4? All right, 2 and 6, right? Now I'm going to place my 2 and 6 here, and I have to play around with the negatives now. Now I know if my product is negative, I have to have two different signs. So I have to decide where that negative goes. Should it go here next to the 2 or here next to the 6? That's correct, next to the 6. So I'm going to set up my answer. I always double check. X times x gives me x squared. -6x plus 2x gives me the -4x. All right, and the +2 and the -6 gives me the -12. So I write my final answer as negative times the quantity x plus 2 times the quantity x minus 6. Circle my final answer. All right, let's check with the PowerPoint. Awesome, we got it correct, all right? And you're gonna notice my answer is in different order than what's on the PowerPoint, and that's okay, right? Commutative property multiplication tells me we can switch those binomials around. All right, so let's look at the next example. We're gonna slide over here. M squared minus 7m plus 10. I always check to see if I can factor out a GCF. In this case, I can't, so I'm gonna set up my parentheses. I'm gonna ask myself what goes in the first terms, and that's m and m. I ask myself, what numbers multiply to get me 10 that add to get me 7? All right, so think about your factor pairs of 10. If you need to write it down on the side, you can. Let me slide that over. All right, 1 and 10, 2 and 5. The 2 and the 5 are what's going to give me that 7. After we figure out the numbers, we have to play around with the signs. Now I know if my product is positive and my sum is negative, both of these terms must be negative. I always double check. M times m gives me m squared. -5m minus 2m gives me the -7m. -2 times -5 gives me the +10. All right, let's double check with the PowerPoint. Beautiful, got it correct. Yes. All right, so let's kick it up a notch. So we've done all the ones where we're factoring when my leading coefficient is 1. Now let's go into when my leading coefficient is not 1. All right, these get a little bit trickier. So if you need to, you can pause the video and copy down examples C and D. All right, but I'm going to go back to this PowerPoint here. We're going to actually look at the steps. Our first step is always to still factor out our GCF. All right, if A is prime, if your leading coefficient is prime, I'm going to encourage you as much as you can to try to guess and check. Use that same method that we did with our leading coefficient being 1. If it's not prime, try factoring by grouping. All right, it's going to be a lot easier if you use factoring by grouping in that method. Our final step, as always, check your work. Make sure that when you multiply out those binomials or all your factors, it comes out to be that original expression. All right, so let's hop into example C. We've got 2x squared plus 13x plus 6. I first asked myself, is there a greatest common factor? No, right? So I'm going to hop right into my example here. Since my leading coefficient is 2, and that's prime, I'm going to try my best to guess and check. And the reason I encourage you to guess and check when your leading coefficient is prime is because when I think about my factors of 2, my only factors is 2 and 1. All right, so I know one of my terms must be 2x, and the other one must be x to get me that 2x squared. All right, now this is where we have to play around with a little bit. So I'm going to look for what numbers multiply to get me 6. So on the side here, I'm going to think in my head 1 and 6, 2 and 3, and that's it. This is where we have to kind of play around. If I put a 6 here and a 1 here, I look at my outer and my inner terms. 2x times 1 gives me 2x, and 6 times x gives me 6x. So I have 2x and 6x. Does that give me the 13x? No, right? So, all right, let's see if we switch these numbers around. All right, if I put a 1 here and a 6 here, my outer terms would become 12x, and my inner terms would become 1x, 12x and 1x. That can give me 13x. So that's the factor pair I'm going to use. All right, now I have to play around with the signs. Well, this one's nice, right? Because I have positive 6. So I know my signs can either be both negative or both positive. But since my middle term is positive, that tells me both of these are positive. So I'm going to write my final answer, because that was a little messy up there. Quantity 2x plus 1 times the quantity x plus 6. I'm going to circle that final answer. Double check my work. 2x times x gives me the 2x squared. Outer 12x plus 1x gives me the 13x. Nice. 1 times 6 gives me positive 6. Beautiful. Let's check our work. We got it. All right, so let's move on to the next one. All right. Example D gets a little bit trickier, right? I look at negative 4x squared minus 8x plus 5. My first step is to ask myself, can I pull out a GCF? And in this case, I can, right? What is my greatest common factor here? That's correct, negative 1. So since my first term is negative, I want to pull out that negative 1 as my GCF. So I pull out a negative 1, I get 4x squared plus 8x minus 5. All right, and this one's a little bit trickier than our original example because you're going to notice that my leading coefficient in this trinomial is 4, and 4 is not prime. All right, now if you try to do guess and check, this is why it becomes a little bit more difficult to do guess and check, because I can have 4x and x here, I can have 2x and then 2x here, all right? So we don't really want to use guess and check. So I'm going to erase this work here, all right? And we're going to start over. And what I'm going to do here is we're going to create a little x, all right? On the top, we're looking for what two numbers multiply to get me AC, that add, to get me B. All right, so I take my A and my C, and this is how we're going to factor by grouping. A times C is 4 times negative 5, which gives me negative 20, and my B is 8. So I'm looking for what two numbers multiply to get me negative 20, but add to get me 8. All right, so think about factors of 20 that add to get me 8. Any idea? Good, 10 and 2. All right, so I start with the 10 and the 2. Those multiply to get me 20. I can get an 8 from that. Then I have to play around with the signs. Since I know it's positive 8, my negative must belong to the 2. All right, so follow with me now because now I want to look at how to factor by grouping. So my goal is to use these now. So I'm going to bring down my negative 1. I'm going to bring out my 4x squared. And what I'm going to do is I'm going to take this positive 8x and I'm going to break it down into plus 10x minus 2x. And then bring down my minus 5. You're going to see I have not changed my expression. These are still equivalent. I'm just kind of expanding it a little bit more. Now, let's get to the fun stuff. Now we're going to factor by grouping. My first two terms here, I'm going to look to see if they contain a common factor, a greatest common factor. And in this case, they do. All right, so I'm going to use brackets here. -1 times. In this case, my greatest common factor is 2x. That's going to give me 2x plus 5. Now I'm going to look at these last two terms, -2x minus 5, and I can pull out a GCF of -1. That's going to give me 2x plus 5. All right, you're going to notice that these binomials here are the same, and that means you're on the right track. So now I'm going to group them together. I have -1 times, these two can go together, 2x minus 1 times the quantity, 2x plus 5. And that's my final answer. The only thing I should probably get rid of is that -1. We don't need the negative. We don't need the 1. We just want the negative sign. All right. I double checked my work. It does give me the 4x squared plus 8x minus 5. All right, let's see if our answer is correct. Awesome. All right. So we've just gone over how to factor polynomials when my leading coefficient is 1. And we talked about some different strategies to factor my polynomial when my leading coefficient is not 1. We can still use guess and check, but other times you can use factoring by grouping. All right, so let's get to our last two examples for today, which these are some special cases. All right, when I take a look at this example here, 2x squared plus 14x plus 3, I have a polynomial, I'm asked to factor it. I have to ask myself, is there a GCF I can pull out of this? Does 2, 14, and 3 share a common factor? No, right? So I can sit here and start trying to create my two binomials, 2x and x. My only factors of 3 are 3 and 1. That won't give me the 14x. What if I switch it? That won't get my 14x. Oh, I'm going to cross this out. There's no way I can factor this. I cannot pull it at GCF. I cannot write this as a product of two binomials. So what do we call this? That's correct. We call this prime. This is our first example in which we're going to call prime. Because the only factors of this expression is itself and 1. So we call this not factorable. We call this prime. All right. So if you take a look to the left, the answer is prime. All right. So then let's look here. 4x squared plus 28x plus 6. Well, automatically we can pull out a GCF here, right? This has a common factor of 2. So 2 times the quantity 2x squared plus 14x plus 3. See anything similar to our first example? That's correct. We've got an expression here that we know we can't factor any further. So do you think we call this prime? No, we don't. That's correct. We cannot call this prime because technically we have factored it. We factor out a GCF. So this would be my final answer for this problem. Okay? So keep in mind, you're going to get a lot of different examples. You're going to get some examples in which you have a leading coefficient of 1. You're going to get some examples in which you don't have a leading coefficient of 1. You're going to get some examples in which you're going to have to factor by grouping. All right. And then down here, you might get some examples where you have a prime number. All right. So what I want you to do now, all right, is to try out these 3 examples. So on the left-hand side, you have 3 examples here. You can pause the video for a moment, try them out on your own, and then unpause the video to check your answers with the colored pen, okay? All right, so go ahead, pause the video. Let's see what you can do. All right, so hopefully you've solved it out. No cheating, right? So let's actually look at our examples. For number 1, you should have gotten the solution of 2 times the quantity 3x plus 2 times the quantity x minus 5. Did you get that correct? Hope so. All right, let's look at number 2. You should have been able to factor out a GCF first, and then your final answer should have been 2 times the quantity x plus 3 times the quantity x plus 1. For number 3, you should have gotten 2x minus 3 times the quantity 4x plus 1. All right. If you didn't get any of those correct, or if you got one of those wrong, please go back and try to find your error now before we head to the second half of our lesson. Okay. All right. So now we're going to bring everything together. We've talked a lot about factoring, and it can get a little bit overwhelming when we have all these different problems. So let's kind of create a chart to organize all of our thinking. All right, so wait, how do I factor that? Let's actually go through this. So in order to factor, our goal is, let's actually play around with this for a little bit. Let's enlarge this. All right, our goal is to factor our polynomial. We want to take our polynomial and break it into all of its factors. Remember to always check your work. You should be able to get to the correct answer every single time because you should be able to multiply your answer out, and it should always equal your original expression. And if it doesn't, you know you did something wrong. All right, so let's go through how do I factor that. The first thing you should always do is to check to see if you can factor out a GCF. If you cannot factor out a GCF, then you're going to move on. If you can, factor out a GCF. All right, if you can't, or if you've already factored out, then you should ask yourself, what type of polynomial are you left with? Is it a binomial with 2 terms? Is it a trinomial with 3 terms? Or is it a polynomial which has more than 3 terms, right? Is it a 4-term polynomial? If it's a binomial, we cannot write it as a product of 2 binomials, right? If you're left with a binomial, you want to check to see if it's a difference of squares. And that's one of those special cases that we talked about in class. All right. If it's a trinomial, I'm sorry. All right. Let me make my head a little smaller. All right, if it's a trinomial, you should check to see if it's a perfect square trinomial. If it is, great, you can move forward. If it's not, go through those examples that we just did. If A is prime, try to guess and check. If it's not, factor by grouping, or use the box method if you remember that from class. All right, the last thing is, what if it has more than 3 terms? If it's a 4-term polynomial, for example, you're going to have to factor by grouping, all right? So I have this little flowchart here as a reference. All right, what we're going to do is we're going to head into our first example, and we're going to kind of use this as a reference. So as I do this, let me set up my screen. I like this little I want you guys to reference this. So before we move on, I'm going to do some TV magic here. I'm going to keep this flowchart here as a reference for us. All right, and I'm going to minimize my head as small as possible now. All right, so we've got a lot of stuff going on the screen. Let's see if this works out now. All right. Sorry about that, guys. All right, on the top here, you have your PowerPoint. On the bottom here, I'm giving you guys that reference, that flow chart. And on the right here, we're gonna actually show our work. All right, it's a lot to look at. On the left here, let's start with our first example. We're gonna use this flow chart as a way to kind of organize our thinking. So in number 1, we have 5x squared plus 20x minus 60. If you need to, you can pause the video and write down these 4 examples because these are the 4 we're going to do together. All right. I'm going to model for you guys what I expect you guys to be doing in your brain. All right. In number 1, I have 5x squared plus 20x minus 60. I go to my flow chart. I ask myself, can I factor out a GCF? In this case, can you factor out a GCF? Yes. What can we factor out? Good. The number 5. So I'm going to factor out a 5. We get x squared, 5 times the quantity x squared plus 4x minus 12. All right. Now I'm left with a trinomial that has a leading coefficient of 1. So what type of polynomial am I left with? A trinomial. I should first check to see if this is a perfect square trinomial. It's not. So now I have to go through the bottom. If A is prime, we should use guess and check. If it's not, let's try to factor by grouping. Well, in this case, my leading coefficient is 1. So I'm going to guess and check. I'm going to set up my 2 parentheses, and I'm going to try to fill this in. I know my first terms are x. I'm looking for what 2 numbers multiply to get me 12 that add to get me 4, or add or subtract, right? Can you think about it? Good, 6 and 2. So I'm going to put a 6 here and a 2 here. Now I have to play around with my negatives. I know since my solution is negative and my sum is positive, I have to have 2 different signs. Since my sum is positive, the negative should go to the number that has a smaller absolute value. So I'm going to put the negative next to the 2, the positive next to the 6, always double check. X times x gives me x squared, positive 6x minus 2x gives me the positive 4x, negative 2 times positive 6 gives me the negative 12. And I get my final answer. Let's check our work with the PowerPoint over here. Beautiful. All right, let's move to number 2. All right, number 2, we have a cubed minus a, this is a little bit hard to read, a cubed minus a squared minus 8a plus 8. So I look at this polynomial. I ask myself, can I factor out a GCF? Nope, they don't all share a common factor. All right, so what type of polynomial am I left with? A binomial, a trinomial, or a polynomial? This is definitely a 4-term polynomial, right? So I'm going to take a look here and I'm going to factor by grouping. I look at my first 2 terms here and I ask myself, what is the greatest common factor of the first 2 terms? A squared. I'm left with a minus 1. I look at my next 2 terms, negative 8a plus 8, and I ask myself, what's my greatest common factor there? Negative 8, right? Since my first term is negative, pull out a negative, and I'm left with a minus 1. You know you did this correct if the expressions inside the parentheses are equivalent. If they're not, then you know you can't group them together, right? So my final answer is a squared minus 8 times a minus 1. I'm going to double check here. I've got a binomial. Is this a difference of squares? No. All right, so this is my final answer. It doesn't have any more common factors. So let's go to our PowerPoint here. Perfect, we got it correct. All right, let's move to number 3. Now, in number 3, we've got a binomial, but before we do that, we want to see if we can factor out a GCF. So in number 3, let's take a look. Can I factor out a GCF? Yeah, right, I can factor out a 3t. So I'm left with t squared minus 9. All right, now inside my parentheses, I have a binomial. I should double check if this is a difference of squares. We've got 2 terms, so bells should go off, all right? We've got a minus sign in the middle, all right? And my leading coefficient is a perfect square, 1, right? And my 9 is a perfect square. This is a difference of squares. So we're going to factor this even further, and we're going to be left with t plus 3 times t minus 3. And that's my answer in factored form. All right, we have to factor everything out. All right, so let's go back to the PowerPoint. Let's see if we're correct. Perfect. All right. All right, let's finally go to our last class example before you guys try some out on your own. Number 4, Number 4, we have 4x squared plus 16x plus 16. So I'm going to ask myself, can I factor out a GCF, a greatest common factor? In this case, yep, we can. We can factor out a 4. So I'm going to do that. 4 times the quantity x squared plus 4x plus 4. I look at this polynomial inside and I ask myself, what type of polynomial is it? How many terms? It's a trinomial, right? So on my flow chart, I want to check to see if this is a perfect square trinomial. So I bring down my 4. In this case, it is a perfect square trinomial, right? We can be left with x plus 2 times the quantity x plus 2. X squared, inner and outer terms, gives me the positive 4x. Positive 2 times positive 2 gives me positive 4. All right, my final answer, I want to write this properly. We say 4 times the quantity x plus 2 squared. All right, and that's going to be my final answer in factored form. All right, so number 4, we got a perfect square trinomial. All right, so you've got your flow chart. We've talked about a lot of different strategies. This was a huge mashup lesson. So let's see if you guys can apply it now. All right, in this you try example here, all right, you have 4 examples. Use this flow chart as a reference if you need to. So what you're going to want to do right now is copy down these 4 examples, pause the video, and try it out. All right, once you unpause, we'll go over the solutions. All right, great. So hopefully you finished examples A through D, and what we're going to do right now is we're just going to go over the solutions. So I'm going to enlarge this a little bit. All right, moment of truth. Let's see if you got it. All right, example A. Your factored answer should be the quantity 2x plus 1 times the quantity x minus 3. Did you get it correct? Hope so. All right, let's look at B. Hopefully you remember to factor out that, that negative 1. All right, your final answer should be the negative quantity 3x minus 1 times the quantity 2x plus 3. Make sure you're listening to the way I'm saying these expressions to my solutions. All right, I look at C. Hopefully those bells are going off because we've got a binomial, a minus sign in the middle, and my first term and my last term are perfect squares. That's going to tell me that this is a perfect square. A difference of squares. All right, so I factor out my 4. I get to my answer of quantity a plus 4 times quantity a minus 4. It's a difference of squares. All right, example D. Woo, this looks like a doozy, but we've got a 4-term polynomial. Nice and easy, right? We factor by grouping. So your final answer should be quantity y plus 2 times quantity y minus 2 times quantity y minus 1. All right. If you had something different for this first term, if you had y squared minus 4, you could have factored that out a little bit further. So always double checking if you can pull out any further. All right, guys, this concludes our lesson on weight. How do I factor that? Hopefully you feel really comfortable factoring some polynomials. All right. And that ends today's video tutorial. I hope this helps. Thank you for joining us today.